Alright, so to start off with scenario 3, we're going to be going over weather and then the flight planning section. So to begin with METARs, a METAR is just an automatic or a manual weather forecasting system that you'll find at most airports. If not, it could also come in the sense of an ATIS, a ASOS, or AWOS system, whichever is at the airport. Just a quick reading, if you look at the picture on the presentation, it shows you the type of the report, the identifier, the date and time of it. So in the picture, it's the first at 1955 Zulu. Whether it's auto-generated, automatic, or manual, the winds, what they're doing, the visibility. If there's an RVR or runway visual range at the airport, it'll show that. What's the current weather, sky condition, temperature, dew point, altimeter, and then any remarks with it. But following that, we have the TAF, Terminal Aerodrome Forecast. So this is just a forecast at the airport on field. And it's very similar to the METAR in how to read it, with a few slight differences. Mainly being that a TAF has a farther outlook or a farther forecast into the future. And if we look at the screen here, we can see, if we look into the text, at Lynchburg, we're at the 16th at 1724 Zulu. Between 1618 Zulu and 1718 Zulu, the winds are going to be 260 at 9 knots, greater than the 6, sky clear. And then continuing on from 16th at 22 Zulu to the next day, the 17th at 1300 Zulu. But these are really just here to get a good, accurate detail of what's going to happen at the future for that airport. So METARs are now, TAF is future. Now, on our way to our baseball game, we're going to also want to look at our winds and temperatures aloft. So when looking at the winds and temperature, we're going to be looking at what altitude we're going to be going to, on altitudes that we're going to be flying through, and we're going to be using this to determine the temperature of the air that the altitude is going to be at, what's the wind speed, and the direction at those altitudes. Next to all of those numbers, there's a bunch of identifiers that will also show which station it's at. Then there is the weather prognostic charts, and these are just charts to show the overall condition of the weather across the country and what's happening. So in the top left, we have weather for the Europe and the Atlantic area for international flights. On the top right, we have a surface prognostication chart that shows the high, shows cold fronts, warm fronts, troughs, high pressure, low pressure systems, as well as the any other information such as that. And then the bottom, we have things that involve, we have a 12-hour and a 24-hour involving the visual and ceiling conditions that will be available at that time. So if we were to take here in Texas, in the bottom, we see that the ceiling is going to be 1,000 and 3,000 feet with about 3 to 5 miles of visibility. Followed up with that, we have SIGMETs, AirMets, and PIREPs. SIGMETs, if we're looking at the picture, still being in the red, AirMets being in the blue, each of which will be color coded. If it's an AirMet, it's color coded. If it's SIGMET, color coded, and PIREPs. So when we're looking out for these things, we're really just looking out, for any possible hazardous weather. So on the screen here, we see that we have an AirMet for icing at 8,000 from the surface to 8,000 here in Texas, with moderate turbulence, in the North Texas, across Oklahoma, or in Michigan. But typically, these are also very specific areas. So as you see, they're not across the entire United States. Even in this picture, it's pretty much the entire United States, but they're confined to specific areas. Now, onto the actual planning of this flight. We need to be aware of airspace. So what airspaces are we going to be flying through? Probably going to take off from a Class D and eventually land in another Class D or Class E airspace. But just knowing what airspaces we're going through, you know, B, C, D, E, or G. I have a feeling that we're not really going to get to the A airspaces. But I guess that really depends on how far you're traveling and how high you want to go to. So just be aware of, you know, what class of airspace you're flying into, as well as the other types of airspace, you know, restricted airspaces, warning areas, alert areas, and MOAs and things like that. Now, onto the aircraft itself. So pretty much so far we've discussed, you know, in the PAVE checklist, we've talked about the environment. So we're getting into the aircraft itself. So when we're looking at performance calculations, we're going to want to know how long is it going to take us to climb out, how much fuel we're going to use, how far are we going to go before we get to our altitude. We're going to want to know what our cruise is going to be like, so that way we can get a good range of our distance and our fuel and how far we can travel to make sure we have everything in there, make sure we have enough fuel. And then we're also going to want to calculate our descent. You know, how long is it going to take us to descend? When do we need to descend? And having important things like that to focus on. On top of that, speaking of fuel, we're going to want to know how much we have, how much we can use. You know, we want to know how far we can travel. So I was using the Duchess POH for both the performance charts and the fuel. So in this case with the fuel, I just used a standard day at 8,000 feet, which gave us a 9.8 for our gallons per hour to use. From that, we can go on to our calculations of, you know, how much gas we're going to burn up with for this amount of time. Now, also, in this case, I used the King Air F90 only because I could not find any good photos with the Duchess. But weight and balance, making sure we're within the weight and balance or performance envelope. So that's, if you look at the screen, that's a combination of calculating the entire weight, as well as figuring out the arm and moment of the aircraft. So we want to calculate how much our pilots weigh, how much our passengers weigh, how much the baggage weighs, how much all the fuel weighs. Put that all together, add our basic empty weight onto that. And then we, you know, take the total weight. We take the total weight in the moment, and we eventually get our envelope of where we're in. If we're too far, if we're outside of our envelope, we're gonna have problems with our weight and balance. So you might have nose low tendencies or nose high tendencies, depending on how you shifted everything about. And then the last thing we need to focus on is our flight plans and NOTAMs. And really, since we're a VFR private pilot, we don't need to focus on instrument stuff. So whenever we go doing this flight, let's go ahead and file, you know, flight following, or even just put in file a VFR flight plan, just for ATC and just for ATC to have it out there. So say if we go down, have an emergency engine failure, and we have to land somewhere. We have to land somewhere in a field or a town or wherever, you know, at least they'll know to come looking for us after a while. And with that, making sure that we have all the correct safety information so that way people can find us. We're going to talk about NOTAMs real quickly. Now, NOTAMs, it's just like an advisory of things that are broken, missing, or need to be fixed. If you look at the screen from Baltia Airlines, it describes it as information that requires wide dissemination and pertains to en route navigation aids, civil public use land areas listed in the airport facility directory, and aeronautical data related to IFR operations. These are also very good for VFR operations, so just because it's helpful, go ahead and use them. But for our trip here, we're going to want to check the NOTAMs for our departure airport, our arrival airport, and if need be, any alternate airports that we could go to for, you know, engine failure or something like that. Anyways, that is pretty much the whole thing. Thank you very much.